Hello children, welcome to K-Tech High School and Junior College. Today we'll be starting a new lesson children, metals and non-metals. So let's begin. Today we'll see the physical properties of metals. So children, what are metals? All the objects or material in the world are made from elements, compounds, or their mixtures. Scientists classified all the elements into three general types, which are metals, non-metals, and metalloids. So let's see what are metals. The objects which you are using, like mobile or computers, are also made up of metals. Let's see the physical properties of metals. So, the first physical property of metal is physical state. Let's see what it is. Under ordinary temperature, metals stay in solid state. As you can see in this picture, the metals are in solid state. But there are some exceptions also. Mercury and gallium are in liquid state even at room temperature. Do you know where mercury and gallium are used? Mercury is used in thermometers, whereas gallium is used in electronic devices. This is just one example. There are many more subjects where mercury and gallium are used. Understood? Let's see the next property. The next property, second property, we have luster. Now children, take a copper vessel, scrub them with lemon and rinse. Light gets reflected from the cleaned surface of metal and the metal looks lustrous. So children, where luster means here shine. So metals are lustrous, that means they shine. Understood? Now see, here we have some examples of lustrous metal. We have copper, silver, iron and gold. So these are some metals which have the property of luster. In our daily life, we can see here the jewelry and also the coins. They also shine. They have the property of luster. Isn't it? Let's see the next property. The third property of metals is hardness. Generally, metals are hard, but there are some exceptions. Sodium and potassium are soft and can easily be cut by a knife. Let's see the next property. The fourth property of metals is ductility. Now, when a metal is pulled through a hole, its wire is formed. This property of metal is called as ductility. Let's see an example to understand it better. Now here we have a copper metal. When this copper metal is pulled through a hole, its wire is formed, a copper wire. So this property of metal is called ductility. Are you understanding, children? What is this property? Ductility. We have many more such metals which can be formed into a thin wire. Here one more example we have is a gold wire. Gold can also be turned into a thin wire. This property is called as ductility. Next property we have malleability. Now malleability is a property where the metals can be hammered and brought into thin sheets. The property where the metals can be hammered into thin sheets is called as malleability. So here gold is the most malleable metal where we can hammer it and can be brought into a thin sheet. This property is called as malleability. Is it easy to understand, children? Yes. Let's see the next property of metal. At number 6 we have conduction of heat. When a metal is heated, there is a flow of heat from one point to another. This states that metals are good conductors of heat. Silver, copper, aluminium are the best conductors of heat. It means when a metal is heated, the heat can be flow easily from one end to the another. So, in short, metals are good conductors of heat. We also have some few exceptions. The next property, number 7, we have conduction of electricity. Now tell me, children, which metals are used to make electric wire? Think, children. Yes, the answer is aluminium and copper. Aluminium and copper are used, these metals are used to make electrical wires. So, metals are good conductors of electricity. Metals are good conductors of electricity, but lead is an exception, which is neither a good conductor of heat nor of electricity. It means lead does not allow heat or electricity to pass through it. So, lead is a bad conductor of heat and also of electricity. The next property we have density. Now what exactly density is? In this picture you can see a gas, liquid and a solid. You can see how tightly packed the matter is. The amount of mass is given in the space. So, in gas, the amount of mass is less, therefore, gas is less dense, isn't it? Whereas in solid, the amount of mass is more, therefore, solid is more dense. So, metals have high density. Are you understanding this, children? Good. Metals have high density. Sodium, potassium, and lithium are exception, having lower density than water. The density of lithium is only 0.53 grams per cubic centimeter. Let's see the next property. Melting point and boiling point. Now what it is? The temperature at which a solid changes into a liquid is called as melting point, whereas the temperature at which a liquid changes into vapor is called a boiling point. Generally, metals have high melting points and boiling points, but there are few exceptions like mercury, gallium, sodium, and potassium. Are you understanding this? The next property, number 10, we have sonority. Now, what is sonority? The ability to produce a sound when struck. Metals are sonorous. They produce a specific sound when struck with a hard object. Means when a metal is struck with a hard object, it produces sound. So this ability to produce sound when struck is called as sonority. You must have seen a school bell. Yes, it is there in a school also. When it is struck by a hard object, the school bell produces sound. Isn't it? We can hear the sound of the bell. So this property is called as sonority. Understood, children? Let's see the physical properties of non-metal. Now, non-metals. Non-metals, we have now just studied the physical properties of metal. So, the physical properties of non-metal would be just opposite to that. Now, let us see the first physical property of non-metal. Physical state. Let's see what it is. At ordinary temperature, non-metals occur as solids. For example, phosphorus, carbon, sulfur. Non-metals can also occur in liquid state. For example, bromine. And non-metals can also occur in gaseous state. For example, hydrogen, nitrogen, and oxygen. Let's see the next property. Luster. You all know what is luster. Non-metals do not have luster except diamond and some iodine crystals. Now, some non-metals are also colorless, while others have different colors. For example, in colorless we have nitrogen and oxygen, and the different colors we have sulfur, which is yellow in color, and coal, which is black in color. We also have some other examples of different colors like bromine. It is brown in color. Understood, children? The next property, number 3, we have brittleness. Now, children, take a piece of coal and hammer it. So what will happen here? The coal will break down into smaller pieces. So this is nothing but the property of brittleness. So some non-metals are brittle. That means they can be break down into smaller pieces. Are you getting me, children? Some non-metals are soft. We have an example, that is diamond. Diamond is an exception. It is the hardest natural substance. The fourth property is ductility and malleability. We have just studied ductility is a property where an element can be brought down into thin wires. It is called as ductility. And when an element can be brought down into thin sheets, that property is called as malleability. Non-metals are neither ductile nor malleable. The next we have conduction of heat and electricity. Non-metals are bad conductors of heat and electricity. That means it does not allow heat and electricity to pass through it. Here we have wood, coal, sulfur powder. Graphite is an exception. It is a very good conductor of heat and electricity. The next property we have density. We have just seen what density is. So, non-metals have low density. The next property is melting and boiling point. Non-metals have low melting and boiling point. Exceptions are solid non-metals, that is carbon and boron, melt at high temperature. So, non-metals have low melting and boiling point. Now let's see metalloids. There are some other elements from metals and non-metals, that is metalloids. Let us see what metalloids means. Some elements have the properties which are intermediate between metals and non-metals. Such elements are known as metalloids. It means where the elements which have the properties of both metals as well as non-metals are known as metalloids. Some examples of metalloids are arsenic, silicon, germanium, antimony. These are some examples. Let's quickly summarize what we have learned in this session. We
Now
have seen the
here in
physical
short we
properties
can
of
see
metal,
all the
physical
physical
state,
properties of
luster,
metals which we have
hardness,
studied in this
ductility,
video. We have
malleability,
physical state,
conduction of heat,
luster,
conduction of
hardness,
electricity,
ductility,
density,
malleability,
melting point and
conduction of
boiling point,
heat,
and
conduction of
sonority. So these
electricity,
are the physical
density,
properties of metal
melting
which we
and
have learned
boiling
today.
point, and sonority.
Let's see the physical properties of non-metal. Physical state, luster, brittleness, ductility and malleability, conduction of heat and electricity, density, melting point and boiling point. Now let's take a look over the notes for today's topic. First we will write new words followed by the glossary. Then question number 1, identify the odd term. Question number 2, we have complete the table, followed by question number 3, give scientific reason for the following statements. Then distinguish between metals and non-metal based on physical properties. Okay, children? That's all for today's session, children. I hope you all have understood today's lecture. So, we will see you in the next lecture with the next topic. Till then, thank you. Take care.